Swagatam Kapardi Mathematics classes. Gurubhyo Namaha. This is your Murali Krishna, mathematics teacher. The lesson is mathematical reasoning for 11th class CBSE students, and the concept is quantifier. To understand this concept, we need some prerequisites. Let me explain the concept. Consider an expression x is greater than 5. It is just an expression x is greater than 5. Now, I want to find whether this expression is true or false. Immediately you ask, without knowing the value of x, how you can decide it is true or false? Yes, you are right. If you assign a value for x, say for example, x is equal to 6, x is equal to 6, then we have 6 greater than 5, which is a true. Suppose if I have x is equal to 2 and 2 is greater than 5, which is false. That means you could find the truth value of this expression after assigning certain value for x. Now, these type of expressions are called statement functions. What do you call? Statement function. Then statement function. An expression may be mathematical or non-mathematical. Mathematical or non-mathematical. Which becomes a statement. After assigning value for is called statement function. In higher mathematics, this is called predicate function. But I don't want to use this word for 11th class students. I use the word statement function. For example, let's see an example. P of x such that x is greater than 5 is a statement function. Statement function. Or I can have two variables also. The two variables q of a comma b is such that a plus b whole square is equal to a square plus b square plus 2a. You can have any number of variables, but it must become a statement after assigning the values. Right. Now, I am going to quantify this statement function. Please observe carefully. I am going to quantify this statement function. What is meant by quantifying a statement function? What is meant by quantifying a statement function? Means I want to decide for how many values of x the statement function is going to be true. For how many values of this a and b, this statement function is going to be true. If you consider the truth value of the statement. Now I have a statement function. I want to quantify that statement function. So here, quantifying. What is the meaning of quantifying a statement function? It's very simple. For how many values? For how many values my statement function is true? Of course, you can test for how many values the statement function is false also. But I confirm the truth. So, what is the quantity of the variable for which my statement function is true? So, this is called quantifying. Now, let me see this one. I have x is greater than 5. Now, for how many values of x this is true? Okay. Now, can I substitute 1 greater than 5? False. Can I say 7 greater than 5? It is true. That means for some values it is false, for some values it is true, not for all. Whereas if you take a plus b whole square is equal to a square plus b square plus 2a. This identity is true for all the real numbers a and b. This first, second one, it is true for any set of real numbers. Now it is true only for certain real numbers. So how to express this? To express the quantifying of the statement functions, we use some special phrases. So, to decide the quantity of the variables for which the statement function is true. Of course, we can use false also. We use some special phrases. Those phrases are called quantifiers. That's it. So quantifiers are nothing but special phrases which quantifies statement function. We have two types of quantifiers. What are they? Number one, we have two types. Universal quantifier. Second one, existential quantifier. So we use these two quantifiers quantified statement function. Let me explain. P of a comma b is equal to, I write a plus b whole square is equal to a square plus 2ab plus b square. Now we know very well that this expression is true or it becomes a statement. This expression becomes statement for every pair a comma b belongs to real numbers. So how do you express it? For all, I write for all a comma b belongs to real numbers. A plus b whole square is equal to a square plus 2ab plus b square, of course in bracket. So this is how. So it represents that this phrase, by reading this phrase, you understand that this identity is true for all. Is true for all a comma b. Now this for all phrase is called universal quantifier. How do you denote? So universal quantifier. Universal quantifier. The phrase for all or for every is called universal quantifier. And denoted by symbol C, just like B and cross it. That's for all. So I can write the same statement function another way. For all a comma b belongs to R. For all a comma b belongs to R. A plus b whole square is equal to a square plus 2ab plus b square. Please note. Second one, existential quantifier. One pair. Now, let me explain this by using one example. Say I'll take x is greater than 5. This x is greater than 5, it is not true for all, but it's true for some. For some means at least 1. That means there exists at least one x for which x is greater than 5. At least one means not all but some. But not exactly one, it can be 1 or more than 1. So whenever there exists at least one x for which the statement is true, to express that we use existential quantifier. Again I repeat, this existential quantifier is a phrase which is used to express that expression is true for at least one value of x. So how do you write this? The phrase there exists is called existential quantifier. denoted by symbol, just reverse E, existential E, and this is reverse E. So how do you write that one? Example. The next concept is when a statement P implies Q, which is called conditional statement. How do you write the inverse, converse, and the contropositive of conditional statement? So the lesson is writing inverse, converse, and contropositive of a conditional statement. Statement P plus Q. You know very well, in P implies Q, P is called antecedent and Q is called consequence, and you know under which conditions this P implies Q is true. Please remember that the truth table of conditional statement, you will understand this very easily. Now let me explain one by one. When a statement is given, statement first I write. It's very simple. This is statement. Right? It is in the form of P implies Q. Now I have another statement. In the P, the place of P, I write negation of P implies. In the place of Q, I write negation of Q. So this is called inverse of P2, P implies Q. So this is inverse. Inverse. Next one, I want to write reverse of this. Q implies P. It is called converse. The next one, I want to write inverse of this. That means negation of Q implies negation of P, which is called contropositive. So when a statement is given in this way, you have to write all these things. For example, P. I go for X belongs to U. Let this true. Next one, Q. X belongs to India. Let this also true. So statement. Which is in the form of P plus Q, which is nothing but X belongs to P implies X belongs to I. That's all. Next one, I go for inverse. Inverse, which is nothing but negation of P implies negation of Q. How do you write? Very simple. This is simply you write negation of the statement. X does not belong to P implies X does not belong to India. Next, come to converse. Converse. A very simple. Write Q implies P. What is this? X belongs to India implies X belongs to UP. Don't bother about the truth value of these statements. Then we go for contropositive. Contropositive. Negation of Q implies negation of P. This is very simple. X does not belong to UP implies X does not belong to I. Truth values of this converse, inverse and contropositive. Let me write in a table form. P statement, Q is another simple statement, P implies Q, conditional statement, negation of P implies negation of Q, their inverse, Q implies P is their converse, negation of Q implies negation of P is their contropositive. As usual, first I take all the combination of T and T. When the both are true, obviously P implies Q is true. Negation of P implies negation of Q. Negation of P means true, negation is false. True, negation is false. Now, my statement negation of P implies negation of Q will become false implies false. In conditional statement, false implies false is also true. Next one, Q implies P, obviously true. Negation of Q implies negation of Q, that means false implies false is also true. Next, we go for true and false. First statement is true, second statement is false, therefore their conditional statement is false. Negation of P implies negation of Q. Negation of P will become false. Negation of Q will become true. False implies true. In conditional statement, false implies true is true. Next come to Q implies false. Q implies P. False implies true. False implies true. Yes, of course, this is true. The next one is negation of Q implies negation of P. Negation of Q means true. Negation of P is false. True implies false is a false, which is given in our conditional statement. Next one. False implies true. Of course, this is a true. What about this? Negation of P, that means true. Negation of Q, false. True implies false is false. Next, true implies false is false. True implies false is false. Next one, negation of Q implies negation of P. Negation of Q means false. Negation of P is true. False implies true is true. Finally, both are false. And both are false, this is true. Now, negation of P implies negation of Q, that means true implies true is true. Q implies P, false implies P is also true. What about negation of Q implies negation of P? Negation of Q, this is false, true, and this is true. True implies true is again true. So, this is the truth table of converse, inverse, and contropositive. The question is, where do we use this? I told you in the beginning, most of the mathematical statements will be in the form of P equals Q. You have to prove these statements. Listen carefully. Mathematics won't accept examples when the statement is true. When the statement is true, you have to prove it theoretically. Again, I repeat, most of the mathematical statements will be in the form of P plus Q. If the P plus Q is a truth statement, by giving examples you cannot prove it, you have to prove it theoretically. Sometimes what happens, you cannot prove these statements directly. Sometimes what happens, you cannot prove these statements directly. So we go for this contropositive method. Why? Look carefully. This P implies Q and this negation of sorry, I made fog here. The negation of Q implies negation of P. These two are identical. These two are identical. That means proving P plus Q same as proving negation of Q plus negation of P. So whenever we feel proving the statement P plus Q is difficult, we go for this negation of Q plus negation of P. Yes, take it. So with this, entire theory part of mathematical reasoning for 11th class CBSE is over. The next videos I am going to do numerical questions, very important from the exercise.